Hello, in this lesson we will learn about the midpoint formula. The learning goals for this lesson are derive the midpoint formula and use the midpoint formula in the coordinate plane to identify midpoint coordinates. The midpoint of a horizontal segment. So we're going to analyze this to have a general idea of how to create or generate the midpoint formula. Let's say that on the coordinate plane they give us these two coordinates 1,3 and 7,3. We label them A and B and we join them with a segment. So we have segment AB. Now we want to find the midpoint of segment AB. One way to do it is just to count the squares, right? You have 1, 2, 3, 4, 5, 6 squares. So the midpoint will be here, right? After 3 squares here and 3 squares here, right? It will be in the middle. That's the midpoint. But we want to calculate the midpoint using these numbers here, not counting squares. So what we do is we realize that the x-coordinate for this midpoint is going to be the average of this 1 and this 7, right? Because remember, the average is the value in the middle. So basically 1 plus 7 divided by 2 will give us the x-coordinate here. And the y-coordinate is 3 because all these points in the segment have a 3 as a y-coordinate. Okay, so the x and the y. So the x would be 4, 1 plus 7, 8 divided by 2, 4, and the y would be 3. Okay, so 4,3 will be the coordinate. So again, remember to use the average of these two to find the x-coordinate when you have a problem like this. Now, let's go into a different problem. Here we have 2 points that are not on a horizontal segment. We have 1,1 and 7,5. Now we're going to join them with a segment, and the midpoint should be around this point here. Now here, because we don't have a horizontal segment, we'll have to do it differently than before to find the midpoint. So these two segments in green are congruent because this is the midpoint. Therefore, this distance and this distance should be equal. Now, I'm going to draw triangles here, as you see. So if these distances are the same, then these triangles could be the same, right? Because these right triangles will generate the same hypotenuse if the sides are the same. And that's the concept we're going to use. So basically this segment here is going to have the same distance as this segment here. And we already know what happens when two segments have the same distance and we want to find this point here. We average the 1 and the 7, right? It's like there is a horizontal segment and we want to find the midpoint as we did before. So to get the x-coordinate, we're going to average 1 and 7. So it would be basically 1 plus 7 divided by 2. That will give us this x-coordinate. Now, to find the y-coordinate, right, this y-coordinate here, we also know that this distance and this distance are the same. Therefore, the y-coordinate is going to be the average of the y-coordinates of 1 and 5. So we average 1 and 5, 1 plus 5 divided by 2, and that will give us the y-coordinate of the midpoint. So as you can see, the midpoint can be found by using the average of the x-coordinates of the two endpoints for the x-coordinate of the midpoint, and using the average of the y-coordinates of the endpoints to find the y-coordinate of the midpoint. Okay? So in general, if we want to name a formula, and we label this x sub 1 comma y sub 1, and this is x sub 2 comma y sub 2, the midpoint will be given by the average of the x's, right, x1 plus x2 divided by 2, and the y-coordinate will be the average of the y's, y1 plus y2 divided by 2. That's the midpoint formula. Now, let's solve a problem here to use this midpoint formula. They say, which is the most specific classification for the polygon form by connecting the consecutive midpoints of each side of quadrilateral ABCD? So they give us a quadrilateral ABCD, and they want us to write the midpoints on each of the sides and then join those midpoints together and see what type of polygon, right, or quadrilateral we obtain. So first, let's find those midpoints, right? We're going to be applying our formula. To find the midpoint of the side AB, we average the x's here, negative 5 plus 1 divided by 2, and then 1 plus 5 divided by 2. That will give us this coordinate here for the midpoint, which is negative 2, 3. Now let's find the midpoint for BC. So same protocol. We're going to add 1 plus 3 divided by 2 for this coordinate here, right, for this x part of the coordinate, and then 5 plus 2 divided by 2 for this part of the midpoint coordinate. So that gives us 2, 3.5. Now, for the midpoint of DC, right, this segment here, or this side of the quadrilateral, I should say, same protocol, right? Negative 3 plus 3 divided by 2, and negative 2 plus 2 divided by 2, which is 0, 0. And for the midpoint of DA, negative 3 plus negative 5, which is negative 3 minus 5, divided by 2, and negative 2 plus 1 divided by 2, which is negative 4, negative 0.5. Okay? So I used the midpoint formula 4 times, and I found all 4 midpoints that I needed. Now we have to join them together and figure out what type of polygon or quadrilateral we have here. So it looks like a rhombus to me, but to make sure that that's the case, I need to apply the distance formula. So I'm going to apply the distance formula 4 times here, right? For this side here, we apply the distance formula between these two coordinates, right? So it will be negative 2 minus 2 parentheses to the power of 2, and then 3 minus negative 3.5, sorry, minus 3.5 to the power of 2. Okay, because remember, this is the distance formula. We subtract the x's and raise to the power of 2, and then we subtract the y's and raise to the power of 2. And that's exactly what I'm doing here. So if you put this in a calculator like Desmos, you will get the distance is 4.03 approximately. Now let's find the distance of this side here. Again, it will be 2 minus 0 parentheses to the power of 2, and 3.5 minus 0 parentheses to the power of 2, which gives you also 4.03. Now for this side, it will be negative 4 minus 0 parentheses to the power of 2 plus negative 0.5 minus 0 parentheses to the power of 2, which gives you 4.03. For the last side, negative 4 minus negative 2, right? Parenthesis to the power of 2 plus negative 0.5 minus 3, parenthesis to the power of 2, which is also 4.03. So we see that all four sides of this quadrilateral are congruent, are the same. Therefore, we can conclude that this quadrilateral is a rhombus. The reason why it's not a square is because these angles, obviously, just by looking at them, are not 90 degrees. So it's a rhombus. Thank you very much for the attention.